Subjective 4, factor in general form, where a is no longer 1. To factor in the form ax squared plus bx plus c, we're going to use the AC method. You can use the guess and check method. It's similar to the previous guess and check method. It's just slightly different. But in this subjective, I'm just gonna teach you exclusively how to use the AC method. Okay. For example, if I want to factor 6x squared plus 13x plus 6, so the AC method say I want to find the product. A times c, a is 6, c is also 6, is 36, and the sum is 13, right? So let me recall, the product is a times c, and the sum, denote s, is b. In this case, b 13, a 6, c 6. So what are the two numbers when you multiply them together? You get 36 and add up to 13. That will be 9, 4. Okay, so what we're going to do with the 9, 4, we're going to split that 13x into 9x plus 4x. So this one, we write as, maybe I'll use different color, 6x squared plus 4x plus 9x plus 6. If you do 9x plus 4x, that's 5 too. And then we're going to group the first two and last two. We're going to group these first two and last two. The first group, I can factor out a 2x. What leaves me is 3x plus 2. And the second group, I can factor out 3. Right? Now 3x plus 2 is the remaining. I have 3x plus 2 twice. I can factor that out. 3x plus 2 times the first terms, what remain is 2x. Second term, what remain is 3. Make sure we have equal sign here. Similarly for b, I have 4z squared minus 9z plus 2. So I want to find the product, which is 4 times 2, which is 8. And then the sum is negative 9. Two numbers multiply to 8 and add up to negative 9. That would be negative 1, negative 8. Negative 1, negative 8. So negative 9z, I can rewrite it as, so let's rewrite the 4z squared first. And then I have negative 1z minus 8z plus 2. Group them. Again, the first group, I can factor out one copy of z. What remain is 4z minus 1. The second group, I'm going to factor out a negative 2. Remember, the leading term is negative here. Well, I'm talking about leading term in this group. Right? I'm not talking about leading term of the whole thing. So we talk about grouping here. So I'm going to factor out a negative 2 for the second group. What remain is 4z minus, run out of space here, 4z minus 1. Let me move it to the left a little bit. 4z minus 1. When you factor out a negative, it changes its side. Factor out 4z minus 1. What remain is z minus 2. On the prerequisites for the exam, I will recommend you check by foiling. Right, so you know that you got it right. Last one. Let's see this. Maybe you want to pause me for a little bit and then try yourself. When you're done, you can unpause me. I want to find the product is 4. 2 times 2 is 4. And the sum is negative 5. Negative 1, negative 4. Right? So this is going to be 2y squared minus y, or minus 1y. You want to write like that. Minus 4y plus 2. Group. Factor out y. For the first group, what remain is 2y minus 1. Factor out a negative 2 for the second group. What remain is 2y minus 1. Factor out 2y minus 1. What remains is y minus 2. And before that, let's check. Okay. You don't have to write this down, but what I don't want to see is this. Purple. What I want to see people is using the guess and check method wrong in this case, right? Guess and check methods work great when the coefficient of a is 1, when this guy is 1. But when it's not 1, you gotta be careful, right? So this is what I don't want to see. So after you found out the product and the sum, the numbers, you say, oh, that will be y minus 1 and y minus 4. That's not correct, right? -1 times -4, that is positive. For one thing, -1 times -4, that is positive 4, not positive 2, right? And then another thing is that y times y is y squared, not 2y squared. So the guess and check methods for this case will be like this. If I was you, I would start out with the 2y squared first. So how do I split 2y squared? Well, there are 2y and y. That's the only way you can do it, right? Or y and 2y were the same thing, right? And then for the last term, you want 2. So one of the parentheses gonna get 1, the other one gonna get 2, right? It could be positive 1, positive 2, or it could be -1, -2. It has to be the same size, right? Because you want positive 2. Let's see what happens if I have negative first. Let's check. Usually you check the inner and outer. You want to check inner and outer, right? Because you know that this one right here and this one right here, you got to write, because 2y times y, that's 2y squared, and then -1 times -2, that's positive 2, right? So you got to write. So all it left to do is check for the middle one, that -5y. Is it come out -5y? Right? So we're gonna check the in and the outer. Remember FOIL, right? FOIL. Inner and outer will be for the middle term. So I got -y here. The -1 times y is -y, and 2y times -2 is -4y. Yay! If you add up together, it'll be -5y. So it works. It works. So that's how guess and check for factoring the trinomial when a is not 1. Like it's slightly more complicated. And you do have to play around a lot more than the other one. I do prefer the AC method though. I do recommend it, because it is slower, but when you got the result, it's solid. You confidently, you know that it's right. Like that. All right. For the next one, we're gonna review factor with difference of 2 square and the sum and difference of 2 cube. Okay. Let's talk about perfect square first. What is perfect square? A perfect square is when you take a square. Say I claim that 4 is a perfect square. So you don't have to write this down. 4 is a perfect square. Why do I say that? Because if I take, because 2 squared is 4, right? And what 2 squared? That's 2 times 2. Right? 6 is not a perfect square. PS is short for perfect square. Why? Because there's no number when you multiply itself, it give you 6, right? But 9 is a perfect square. 9 is, because 3 times itself is 9, right? So a number times itself, when a number, when you can write a number as a product of some number times itself, that is a perfect square, right? So in terms of variable wise, I say x squared is a perfect square. Why? Because x times itself is x squared, right? X plus 1 quantity squared is a perfect square. Why? Because x plus 1 times itself is x plus 1 square, right? 2 copies of x plus 1. So you get the idea of perfect square. So in short, we have a plus b squared, a plus b quantity squared equal to a plus b times a plus b twice. And if you void this, I'm not going to do it for you here, since this is review. If you void this, you're going to have a trinomial. You have tri mean 3, right? 3 terms. You have a trinomial, right? What I don't want to see is this, which is very common things that students do. I guarantee it's gonna be at least have a class gonna do this on a prereq, no matter what I said. I hope you're not one of them. A minus b quantity squared is the same thing. A minus b times a minus b twice. And then when you FOIL it, you get a trinomial. This part right here is recall things. I'll go through this. So 3x squared quantity cube. Choose the correct answer. Well, the exponential rule is this: if you have a times b quantity to the n power is equal a to the n times b to the n, right? Or another way you can do this is you take a times b times a times b times a times b. How many times? N times, right? It's like x squared, you x times x, so 2 times, right? X cubed, x times x times x, x to the 4, x times x times x times x, 4 times, right? But you don't want to do that. You want to use a shortcut. You want to use this rule right here. You want to use that rule, right? So what I'm going to do, so 3x squared quantity cube is equal to, well, in this case, 3 is a, so be a to the n, 3 to the cube, and then b is x squared, so x squared to the cube. Simplify this, 3 cube is 27, x squared cube is x to the 6, not x to the 5, not x to the 5th, right? Because x squared, how many copies of x squared? 3 copies, right? X squared times x squared times x squared. Each of the x squared is 2 copies, so that'll be 6 copies, right? So x to the 6. So that'll be the answer. I'm gonna give you the answer for this one. Why don't you do it yourself? But I'm gonna give you the answer for this one. Be 4 to the 5th. My calculator, 4 to the 5th equal. That'll be 1024 over, oh, I forgot. A cubed to the 5th is a to the 15, and then 3 to the 5th is 243, and b to the 5th. That'll be the answer. Box it nicely. X to the 4 square. Well, this one there's no shortcuts. All you have to do is write it out twice, right? And then you FOIL it. And when you FOIL it, you should have trinomial. It's gonna be x squared plus 2 times 8x plus 16. Right. I'm doing shortcuts here. From this step to this step, there's another step. I recommend you write out using FOIL. All right, let's practice this. X squared plus 14x plus 49. AC method, right? Or you can use a you can use yes and check because the coefficient of a is 1. Okay? So find 2 number, multiply to 49 and add to 14. 7 and 7, right? Done. X plus 7 times X plus 7. Don't stop it right here though. You're gonna have to simplify this. That will be X plus 7 quantity square. That's my 7. I don't know, look kind of weird. What about this one? X squared minus 10x plus 25. Because a is 1, you can use that guess and check method. Negative 10, and the product is negative 10. I'm sorry, the product is 25. The product is 25, and the sum is negative 10. Negative 5, negative 5, right? So x minus 5 times x minus 5, which is x minus 5 squared. So that is perfect square, if one factoring perfect square. Factor differences and sum of squares. I have a squared minus b squared is equal to a plus b times a minus b. Okay. I'm not gonna, maybe I'll do this out. So why is it true? Let's see. Let's prove from right to left. A plus b times a minus b. Is it equal to a squared minus b squared? Well, one way to find out is to FOIL them. So a times a, that's a squared. A times negative b, that's negative ab. B times a, that's positive ab. B times a times b is the same thing. And b times negative b is minus b squared. These two cancel because they are opposite terms. Right? So all you have left is a squared minus b squared. So yes, they are equal. A squared plus b squared, fortunately for us, because less work for you, is prime, right? Yeah, you cannot find a product of two binomial multiplied together to give you a squared plus b squared. It's prime. X squared minus 4 squared. Well, I know it's not prime because it's a minus, it's difference, right? What if I was you? I'm gonna remember a squared minus b squared. We need, so a in the term a is x, right? If I was you, I'll do this. A is x. And what is b? Not 4, 2, right? Because 2 squared is 4. X squared minus 2 squared. A squared minus b squared. So a is x, b is 2. A plus b times a minus b. Well, a is x, so x plus 2, right? A plus b, a minus b, so x minus 2. Then you're done. For this one right here, same thing, right? Your goal is to make it in term a squared minus b squared, right? Something square minus something square. And in this case, a is the, notice that I'm using big A and big B, capital letter, not just little letter. It implies that A and B does not have to be a single factor, right? It could be a chunk. It could be, I call it a blob, right? It's a blob square minus another blob square, right? So in this case, what is my blob? 21. Oh, actually, we run into a little problem here. Before we do this, I remember the first step is GCF, right? Remember the greater common factor. A squared and b squared, nothing you can factor out, but between 21 and 144, you can factor out something else. You can factor out a 3, right? You can factor out a 3. So between 21 and 144, I can factor out a 3. GCF always come first. So I'm going to factor out a 3 first. And then what remains? What remains does not look good. Did I make a mistake here? I think I make a mistake. Did I make a mistake here? Oh, it's supposed to be 121, not 21, 121. I'm sorry about that. 121. 121. Okay, so well, but it's a good thing. It reminds us that we have to look out for GCF first, right? In this case, we don't have GCF. 121 and 144, there's no common factor between those two. So blob square minus blob square. All right. Well, inside the parentheses, there's a, right? Because a square is a square. What about 121? What number when you square give you 121? Right? You can take 121 square root 121 and it will tell you be 11. Right? Similarly with 144, what number when you square give you 120 144? 12. And then there's b. Right? It makes sense, right? Because 11 square is 121 and a square is a square. Right? Same thing was 144 b squared. All right, now you're gonna establish what is your A and what is your B. This is my A, and this is my B. Right, let me use different color. I don't want to use green. I'm gonna use blue. That's my A, and that's my B. What inside the parentheses? Parenthesis. That is my A, and that is my B. So A plus B times A minus B. Well, A is 11A, plus B is 12B, and then A minus B. Well, I should have said big A minus big B. Big A is 11A, and big B is 12B. Okay. What about x squared plus 25? Well, this one. Prime, right? The best you can do is x squared plus 5 squared, and then you see that, oh, that's a squared plus b squared. That is prime. This one. X plus 1 quantity square minus 81y squared. Okay. So in this case, I have my a square. I have my a square. My big A is x plus 1. If you remember what I say, blob square minus another blob square. Right? So here I have x plus 1 quantity square. And my A, let me use blue. My A, that's x plus 1. A square, x plus 1. Right? What my big B square? What is my big B square? Well, the y in here, right? And then what number when you square give you 81? 9. And what inside the parenthesis, that's your B. So I have I have a squared minus b squared. So that means a plus b. A is x plus 1 plus big B. Well, big B is 9y. And then times a minus b. Well, big A is x plus 1 minus big B is minus 9y. That's all you can do. We're done. This one is, all right, let's do this one. So again, I need to establish my a square minus my b square. Right? Well, a square will be 9y squared, right? Because y squared is y to the 4. And then big B squared will be 10z. That is my A, that is my B. Does it help? Label it out. Big A plus big B. Big A is 9y squared. Big B is negative 10z. Big A minus big B. 9y squared minus 10z. That's all we can do. Factor sum and difference of two cubes. The cubes. Okay, the cubes. I have a cube minus b cube is equal to a binomial. That's right there, a binomial, because there are two terms, times a trinomial, because it's three terms, right? I'm going to show you for a workshop on Monday. I'm going to explain a bit more about this, okay? But for now, it's kind of difficult to explain things via Zoom because I use my hand gesture a lot. I walk back and forth to class too. So I'll show you maybe in the lecture so everybody can listen to it. But for now, just embrace the rule for now. Right? Just trust me on the rule. AQ minus BQ is equal to A minus B times A squared plus AB plus B squared. And then AQ plus BQ is pretty much very similar. All you see is the difference in the size. That's all, right? It'll be A plus B times A squared minus AB plus B squared. And let's try it out this one. X cubed minus plus 125. That's definitely the sum of two cubes. Right? That one. So I need to establish what is my B, what is my A. Right? Here I know my A is X, right? Because that's X cubed. A cubed, X cubed. So X cubed. Maybe I can do a little parenthesis if I want to. To establish that is my A. What is my B? What number when you cube give you 125? So 5. Right? So that is my B. So we established A is, let me write out here in yellow. A is, I'll show it in blue. A is X, B is 5. All right, now we're gonna expand this. It's gonna be a binomial times a trinomial. A plus B, right? A plus B, that's the rule right there, A plus B. So A is X, so X plus 5, right? And then what's next? The trinomial is A squared. So that means A squared, I mean A times A, right? A times A, so X times X, A is X. So X times X is X squared minus A times B, so X times 5, or I like to write it 5X. Plus B squared. B squared is 5 times 5, or 5 squared, which is 25. Let me remove the parentheses for now. And that's it. We're done. We're done. We're done. Similarly for part B, you need to establish what is your A and what is your B. So parenthesis cube plus parenthesis cube. Well, here will be X, right? That's pretty obvious. And 27y cubed will be 3y, right? Because 3 cubed is 27, y cubed is y cubed. That is my A, and that is my B. Expand. Binomial times a trinomial. A plus B. Now let me write down here so I don't forget. A is X. B is 3y. Okay. If A is X, A plus B will be X plus 3y. And then for the trinomial, I have A squared. A squared is X squared. Minus AB, X times 3y, so 3xy. And then B squared. Well, what's B squared? Let me make it B squared. B squared is 3y quantity square, right? The square is applied for both, not just y. I don't want to see 3y squared. It's gonna be 9y squared, right? Because 3y squared is 3y times 3y. Right, so this right here equal to 9y squared. And we're done. Few more, we're almost there, I promise, we're almost there. All right, here, now we come to the difference of 2 cubed. Let me roll, I write it like that so you can see the rule. Again, we're gonna establish your A and your B. So, parenthesis cube minus parenthesis cube. That'll be X here, no argue about that. What about 343? What number when you cube give you 343? You can take a cube root of that. Oh, 3, 4, 3. 7. 7. So let me write out here. My A is X, my B is 7. Okay. Binomial times trinomial. So that'll be x minus 7 here, right? A minus B. It's the rule up there, A minus B. Move this away. And then A squared, so it'll be x squared plus A times B, 7x. Plus the last term will be B squared, that'll be 49. So far, so good. All right, part D. All right, this one, first thing first, I don't know about you, but I see GCF. Is it in descending order? Yes, it is in descending order, right? X to the fifth is the degree is larger than x squared, so it's been written in the front. Remember what the little note I put up in during during the lecture today is that if your leading term carry a negative, you had to factor that negative out, right? So between negative 432 and 2, what can I factor out? Hint, they both even number. When I say they both even number, means they both divided by 2, right? All even number divided by 2. So I'm going to factor out a negative 2. Next, to the variables, x to the fifth and x squared, I can factor out 2 copy of x, so x squared. What remains? If you take negative 432 divided by negative 2, that'll be 216. And then plus 1. Right? When you factor out negative, it changes its sign. Oh, x cubed. Forgot about that. X cubed there. Good. Now we can establish what is my, I'm not there yet. I had to establish what is my A and what is my B. Right. So negative 2, this negative 2x squared right here is outside the parenthesis. It's the GCF. Nothing I can do. Leave it there for now. I'm not going to pay attention to it. Right. At the very end, I'm going to bring it down. But right now, ignore it. What I want to do is take care of this one first. Take care of this one. Right. That is my sum of 2 cubes. Right. So go down here. I have, let me put the parenthesis here. I have something cute plus something cute. Well, the second one, that's easy, 1, right? Because 1 cube is still 1. For the first term, that's x here. And then 216. That's 6. Right? Because 6 cube is 216. All right, now you got your A and you got your B. That's your A and that's your B. So let me write here. A is, let me write somewhere else. I have enough space. Let me write down here. A is 6x and B is 1. Right? Equal. Right. Let me rewrite the rule in yellow here. A cubed plus B cubed equal A plus B times A squared minus AB plus B squared. Apply that rule. A is 6x, B is 1. Then A squared. Ooh, when it comes to A squared, and for the complex things like this, I recommend you do this. And then 6x times 6x. Right, 6x times 6x twice. That'll be 36x cubed. Right? So it'll be 36x cubed. Plus A times B. So 6x times 1 is 6x. Plus 1 squared, which is still 1. That one done. Last one. I have 16x to the fifth minus 54x squared y. First thing first, I see some GCF here, right? 16 and 54. I see 2, right? I can factor out a 2. But by the way, first thing first, it is in descending order. Forgot to mention here that between 16 and negative 54, I can factor out a 2. X to the fifth and x squared, I can factor out x squared. Oh, you know what? One more thing. Oh, I forgot about that. Remember back, let me back it up. In part D, I say that the little green part right there, the negative 2x squared, I said that we ignored it for now. We're gonna bring it along. We're gonna bring it down. We're gonna bring it down at the very bitter end. So we was at the bitter end, so we put it down here. So that'll be negative. Let me remove the parentheses. I'm gonna bring it down, negative 2x squared. We have to. There you go. That's your little GCF. And that is my complete answer. Forgot about that thing. All right, onward for the last one. Yay. 2x squared. I factor out 2x squared. So what remains? That'll be ax. My hand getting tired. Ax cubed. X cubed minus 54 divided by 2. 27. I make a mistake here too. Did I make a mistake? Yeah, I make a mistake. I meant to put a y there. I meant to have a y there. I meant to have a y there. 16x to the fifth times y. So I have to factor out a y as well. So what remains is 27. Just 27. I guess just 27. Again, we're gonna leave this GCF alone for now. Right, we'll put it back at the very end. Right now, I should only focus on factoring the difference of 2 cubed. So ax cubed, so something cubed minus something cubed. 27 is easy. That would be 3 cubed. Right? Ax cubed, that would be what? 2x quantity cubed. And now my A is, we put A is 2x, B is 3. Okay. A minus B. So 2x minus 3. And then A squared. A squared. For the trinomial, you start with A squared. A squared is 2x times 2x, right? So A squared is 4x squared. So 4x squared plus AB, A times B. So 2x times 3 is 6x. Plus B squared. B squared is 9. And bring down that GCF. That's the very end. We are finished. Thank you for listening.